Hello, everyone. We have a joke in our scientific community that if we understand it, then it's no longer AI. You see, for the vast majority of our history, AI has lied in the realm of science fiction, right? As a result, it's now still really hard to shake off that air of mysticism. You'll find many articles that talk about what AI will do very soon in the future and its potential. But it's very rare that you'll find some really informative article about what AI can do right now. Even rarer to find articles about what AI cannot do. My big hope with this talk is to put my little pebble in filling that gap. There are many more things in the world that are not AI than the things that are. I feel like I will be doing you a disservice if I only mention negative examples. After all, you're supposed to learn about AI. Let me just start by mentioning a few tangible examples. I'm going to start by asking you this question. What do you think Netflix, Amazon, and Spotify have in common? So the answer is that all of these three systems they work by a very simple principle. It's that similar people will do similar things. Netflix and Amazon, the way they make money is by recommending you products that are liked by people who are similar to you. And similarity here means something very specific. And so you and I, as consumers, we are defined by what we're buying online. So if we buy very similar things, thereby we are similar consumers. You are very likely to buy something else that I have already bought. So by that logic, then Netflix is going to recommend you that movie, or Amazon is going to recommend you that product. And similarity here is not a binary thing. It's not like you're either similar or you're not. Similarity comes in degrees. Human brains are really good at telling when two things are similar or not. But we have to ask ourselves, how did we attain this ability if not by experience through many other examples of things that are not similar? And this key question brings me to machine learning and reality check number 0. Machine learning says when something is too hard to define, like similarity, then learn it by example. Now, machine learning is a very trendy type of AI that was born out of the fusion of several applied mathematics disciplines, statistics, computer science, operational research, list goes on. But the attribution game is not what's important here. What's important is that machine learning developed its own distinct culture based off that simple mantra. Now, that mantra, learned by example, captures only one aspect of human intelligence. The paradigm of learning by example doesn't really explain abilities like ingenuity, our ability to invent. It doesn't explain things like generalizability, our ability to excel at any new task. It doesn't explain future learning, generalizing with very few examples. Continual learning, being able to generalize with few examples, but all the time. It doesn't explain things like causal reasoning, our ability to understand cause and effect, and therefore being able to deduce the laws of nature. And it doesn't explain consciousness. I'm not even going to go there. So we think that for any AI to be worthy of the title general AI, it needs to satisfy at least this criteria. And right now, we're very far from achieving those things. So, time for myth numero uno. An AI is a machine. Machines don't make mistakes. Therefore, an AI is always right. So what you're seeing here is a video game called Ghost Runner 7. This game is famous in the machine learning community because it was the subject of an interesting experiment. So you see, in machine learning, there's an even smaller subfield called reinforcement learning. And in a typical reinforcement learning problem, the goal is to train a virtual AI agent, in this case the boat, to do well in a virtual environment, in this case the water racetrack. And reinforcement learning does that by giving the agent little rewards every time it does something good. Sounds simple, right? But the catch is that we have to define what is meant by good here. What would the model do if we told it to maximize the amount of points that it wins from the game? After all, that's the very definition of a good gamer, right? What could go wrong here? You remember those green little thingies that the boat collects? Turns out that these thingies give the boat the maximum number of points you can get from any collectible. Now, if you speed up the video, you will notice that the agent has literally found a loophole by circling around the same collectibles so that it can maximize its score endlessly. Now, obviously, this beats the point of being a good video game player, right? So, what went wrong here? Well, we set the wrong goal. We should replace doctors and experts with machine learning models because humans make mistakes whereas machines don't. What could go wrong is that we could use the wrong data. Here you have a tweet by Geoffrey Hinton, one of the pioneers of deep learning. In his tweet, he's saying, suppose you have cancer and you have to choose between a black box AI surgeon that cannot explain how it works, but has a 90% cure rate, and a human surgeon with an 80% cure rate. Do you want the AI surgeon to be illegal? Now, obviously, Geoffrey is not advocating for surgeons to be replaced yet, but I do suspect part of him kind of expects that to happen at some point. But the point of his tweet is really to drive the conversation, for people to express their worries, their opinions around AI. My take on this is that, if I was, let's say, a stakeholder in this bet, I don't know anything about how representative my body is of the cases to which the AI has been trained on. So the bet really depends on the stakeholder, right? If I was a patient, then my risk is more complicated than just something that depends on accuracy alone. But let's say if I was a regulator, if I was a policymaker, then, according to those success rates, I would say that I'm listening.